I want to talk about not just local extremas anymore, but the absolute extreme and how different these are. So these are a little bit more shorter in terms of what the main goal of this problem is. But let's analyze this problem and let's see what we're really talking about here. So the first thing with these problems is you want to take the derivative. All right. So the first thing we're going to do is take the derivative. So you want to find the absolute min and absolute. This word extrema, it's actually plural. And so what it's actually meaning is that we should find the local, well, the absolute max and the absolute min of this graph. All right. So the first thing you want to do is problem is take the derivative. So again, my y prime will be minus 3x squared. And we're going to set this equal to 0. All right. We're going to set this equal to 0. We're going to set this equal to 0, right? And then we could just divide by -3 on both sides. We get x squared is equal to 0. Taking the square root of that, which gives you plus or minus 0. So x is really equal to 0. There's no plus or minus 0, all right? So, and this will be your actual critical point. This will be a critical point. So you always want to find your critical points first. That's why we take the derivative first to find our critical points. And then here's what we do. We take our critical points along with the interval and plug in those values to see which one will be the highest, which one will be the lowest. The lowest will always be your absolute min, highest will be your absolute max, right? So f of -3, f of 0, because that's one of our points, and then simply f of 3, right? Now you plug these back into the original function, not your derivative. That's very important. All right, so this will be 4 minus -3 cubed. All right, and this will be 4 minus 0 cubed. This will be 4 minus 3 cubed. And again, you could see that this will be 4 minus 27, which will just add to be 31. This will be 4 minus 0, which will just be 4. This will be 4 minus 27, which will just be -23. All right. So this is our highest value. This is our lowest value. So we could put everything in terms now, in word. So we have an absolute max. And here's how I write it. We have an absolute max of the value we get when we plug in our x value. So we have an absolute max of 31, where x is equal to -3. And we have an absolute min of -23, where x is equal to 3. And this is what we mean by our local, well, not our local, but our absolute max and our absolute min.